the previous session, we have just seen the salient points of how to draw the projections of points, and also we have seen there the point may situate in any one of the four quadrants, that is the point may situate in first quadrant, second, third or fourth quadrant, and also we have seen that depending upon where the point has been situated, we can see that the top view and front view of that particular problem will be different. And if you just remember, recollect back, if the point is in first quadrant, we know that the point is above HP and in front of VP, and if we draw the top view and front view, we have seen that front view will come above XY line and top view will come below XY line. Now if the point is in second quadrant, that is the point is above HP and behind VP, then we have seen that both top view and front view will come above XY line. Then if the point is in third quadrant, that is point is behind VP and below HP, then we have seen that the top view will come above XY line and front view will be below XY line. Then finally, if the point is in fourth quadrant, we have seen that both top view and front view of that particular point will be below XY line. And also we have seen a general conclusion that whenever we view from the front view, we see only HP details, and whenever we see from the top view, we see the VP details. That is, I can say, let us say if I want to look from the front, I can say that whether the point is above HP or below HP. And also you have seen that if the point is above HP, then the front view will be above XY line, and if the point is below HP, then you have seen that the front view of that particular point will be below XY line. Similarly, with reference to vertical plane, wherein we have to view from the top view, I can say that if the point is in front of VP, then we know that top view will come below XY line. Finally, if the point is behind VP, then we have seen that the top view of that particular point will be above XY line. So with this introduction, let us do some basic problems. Okay, now let us consider we have a point A. A point A, let us say it is 50 mm above HP and 30 mm in front of VP. So how to draw the projections? Now just remember, whenever you are doing orthogonal projections, no need for you to draw those planes which are written HP, VP at 90 degree, not required. You are supposed to do only the final front view and top view after visualizing this particular problem. Anyway, now I told you that point A. I told you that point A is above HP and in front of VP. Let us say this is a problem. Let us say I have given this above HP by 30 mm. Let us say it is in front of VP by 45 mm. I want to do the projections of this point A. So how do we draw projection of points? First thing, I need to draw the XY line, which is nothing but a reference line, which is the intersection of HP as well as VP. So we draw XY line, and XY line we should draw little bit medium darkness, so it should be darker line only. Okay. Now I want to draw the projection of point A, which is in front of VP and which is above HP. Now since this particular point is above HP and in front of VP, then the point is in which quadrant? Now we can see that point is in first quadrant. Now since the point is in first quadrant, we know that front view will be above XY line and top view will be below XY line. Now front view above XY by what distance is given? The point is 45 mm in front of VP. Okay, so that the point is 30 mm above HP. That would say that the front view point is above HP by distance equal to 30 mm. So I will just indicate that. Then I should draw this line very light. Remember, this is a projector. So projector should be very light line. Then this is the point A dash, which is the distance I taken as 30 mm. Then it is in front of VP by 45 mm. That is the top view point will be below XY line by distance equal to 45 mm. Remember, top view and front view point should be on the same projector, and that projector should be as light as possible. So I will just draw that projector. I will take this distance as 45 mm. Then this is point A. So that's all. So this is the projection of point A, which is given in this particular problem. But remember, I need to show the dimensioning also. So just dimensioning. Now since you are doing this particular problem in your sheet, either I think you will be doing in your drawing sheet or in the sheets or A4 sheets which you are going to use. So what you do is, especially to show the dimensions, you just follow this convention. Let us say from point A I will take some 5 mm distance. Then I will just draw a line equal to 10 mm distance. That is, you leave 5 mm, then take 10 mm. Similarly, the point is, I want to measure from XY line. Now what you do then, I will just simply draw this another light line. I will draw this light line. Then at the middle, I will show the distance. What are the distance I given? I given distance as 30 mm. So I can just simply print, or I can just write this 30 mm. Then I need to show these arrows. So let us show these arrows, a very small arrows like this. Okay, so this is the distance 30 mm which I have taken in the front view. Similarly, I need to show the dimensioning in the top view also. So as I said, what you do then? Again, as I said, from this particular point, you take 5 mm distance, or you take some convenient distance. It need not be 5 mm. Just take convenient distance on both the sides, same distances. Then mark this as 10 mm. Okay. Then join this line. Again, this line should be a light line. Then in between, I will type, or I will write this 45 mm. Then again, you show this arc or show this arrow. Remember, this particular arrow what you are showing should be depending upon the length. Let us say if the length is little bit more length, then I can show this arrow more pronouncedly like this. Let us say if I am showing that length to be of only of this much length, then accordingly you show this arrow. Is it clear? But anyway, I think all these things you will be doing once you do some more number of problems. But anyway, now onwards I will not explain about this dimensioning. So dimensioning I am just telling you only for this problem. For the next problem I will just concentrate on how to work out the problems, and all other detailing and all you have to follow. Okay, now let us say I will consider another point B. Let us say I have another point B which is in HP and 25 mm in front of B. I just considered some point. Okay. Now this particular point is in HP and 25 mm in front of BP. Now the most thing is I should draw the XY line. So draw the XY line. I will draw the XY line. Okay. Then, if you remember, since the point is in HP, if I look from the front view, since HP distance is 0, that is H distance is 0. Since that is 0, where do you get the front view then? Then I should get front view on XY line itself. So that I will mark this as B dash. Is it okay? Now, the point is 25 mm in front of BP. Now that means say that the top view point should be, because remember, if I say point is in front of VP means the top view point should be below XY line. So I will just draw this projector. Distance equal to 25 mm. Then I will mark this as B. And remember, again I am just insisting on you that these are what? These are projectors. Since they are projectors has to be as light as possible. So it should be a very thin line. Remember, this line joining top view, front view should be a thin line. And this is what I wanted. That's the reason I can just show this little bit more prominently. I can show this. Is it okay? Now similarly, I just said this. Then the distance is 25 mm. Okay, now tell me, this particular point is in which quadrant? Is in which quadrant? Okay, now I will just show you that. Now let us say this is my quadrants. I just hold this. Now I am looking from the front. Now the point is in HP and it is 25 mm in front of VP. That is, it is 25 in front of VP. So the point is here. So the point is in which quadrant then? Now we can say this particular point, either it may be in first quadrant, or I can also say it may be in which quadrant? What is this quadrant I am telling? This is first quadrant, this is second quadrant, and this is third quadrant, this way it is fourth quadrant. Now since the point is in HP and it is in front of VP, now I cannot say it is only in first quadrant. So I can say this particular point P, either it may be in first quadrant or fourth quadrant. Remember, whenever I give a point is in HP, we can have that possibility. The possibility in this particular case is the point may be in, as you can see here, point is here now, first quadrant, anyway it is in front. So I can consider this also. So this is also we consider, this is the extension of your VP. Okay, now the point is here. Now it is in front of VP. Obviously, I can say that point may be in first quadrant or it may be in fourth quadrant. Okay, so that's what I am going to show here. So I can here say point B is either in first quadrant or fourth quadrant. Is it clear? Okay, now let us go to some other problem. Let us say we have a point C. Okay, let us say point C is below HP and behind VP. Okay, now what do you mean by point is below HP? Then what do you mean by point is behind VP? Again, see, you need to always see the planes and keep on visualizing, not required, because anyway I told you the procedure. So what is the conclusion I had told you in the previous class, which I had told you even at the beginning of this particular session. I told you that if the point is below HP, then the front view should be below XY line and the point is behind VP. Since the point is behind VP, top view should be above XY line. Let me say that the front view will be below XY line, top view is above XY line. So whenever I have that particular projection, which quadrant the point now lies? Now I can say the point is in third quadrant. Okay. Again, let us say I will give this distance as some 25 mm. Let us say it is behind by some 40 mm. Okay. Now as usual, I will draw the XY line. Now the point is below HP by 25 mm. So the front view should be below XY line. So I will simply draw this projector and I will mark this point as C. Whether it is C or C dash. C dash. Why it is C dash? Because it is the front view of this particular point. So I should write as C dash. And distance is 25 mm. Then it is above XY line by a distance equal to 40 mm. Since this is top view point, I will simply indicate it as small c. Is it clear now? Let us say I have given in the problem, let us say I have given, we have a point P. Point B, I have just given this particular problem where I will say that this particular point P, its top view, let us say I will say its top view is 40 mm above XY line and its front view is 20 mm below the top view. Okay, now tell me about this. So again, analyze the problem carefully. Okay, now analyze the problem carefully. So as usual, I have just given the final projections. See, as you can see in these particular problems, I have just given the location of the points. But in this particular problem, I have given the direct projections. So what are the direct projections? That is, we have this XY line. Then I have given that top view is 40 mm above XY line. So I will just take this particular point. Let us say point P is how much distance? It is 40 mm above XY line. Then it is given that front view is 20 mm below the top view. So this is the top view now. So that the front view will be somewhere here I will get that. So this is point front view now P dash. So I can say this is 20, this is 40. I just draw the projections. Now I want you to say this particular point is in which quadrant? Yes, so this point in which quadrant? Just remember what I told you earlier. Earlier I told you that if the points, both the points are above XY line or both top and above XY line, then the point should be in second quadrant. Is it not? Similarly, if I say points are below XY line, then we have seen that it is in which quadrant? Fourth quadrant. Now say this, what I have done here. So here, this is a problem wherein the front view is above, top view is below. So this point in which quadrant? This point is in first quadrant. What about this? Again you see this, the point is front view is below the top view or front view is below the XY and top is above. So this is in which quadrant then? Third quadrant. Here I told you that it may be either first or fourth quadrant. But now we can see this particular problem, the point is in, I can say now we need to write because anyway I want you to write, I want you to say which quadrant this particular point is lying. Now I need to write that. So what I will write now? I will just write that point, which is that point now? P. I can write point P is in which quadrant? Second quadrant. Not only that, you should write the position of the point with reference to the planes also. Now what is that you should write now? Now I can write point is, point P is, tell me. So what about its front view? See now we can see front view is 20 above XY line. That means what? Always remember, I told you that in the second quadrant, if I say that point second quadrant means the point should be above HP and behind VP. Okay, now tell me it is how much above HP as you can see here, because front view is here. Now since the front view is here, now I can say point P is 20 mm above the HP. Okay, and P is, what about the reference to VP? I given 40, now it is behind now. So I can write point P is 40 mm behind the VP. Is it clear? So now as you can observe, if I give any problem, no need to remember anything. You have to understand the concept. So if you understand the concept, I can give any problem to you so that you can just get it. Okay. Let us say finally I will do one more problem. Okay. Let us say we have a point Q. I have just given that point Q. Let us say point Q. Both its top view and front view coincides and it is below XY line. So I just given that point Q 40 mm below the XY line and both top view and front view coincides. Okay, tell me what about this? I just written both point is coincides. So as usual again I have given the projections. Okay, so once as I give projection I should draw this XY line. Now it is given that this particular point 40 mm below XY line represents both top view and front view itself. So I will simply draw this. I will take 40 mm. Then let us say this point is Q as well as Q dash. Now you can clearly tell me now. This point is in which quadrant? This point Q is in fourth quadrant. Not only that, the point Q is 40 mm below the HP and 40 mm in front of VP. Understood? Yeah, okay, I will do one more problem wherein I have given the projection of 2 points. Okay, now let us say that the problem goes like this. 2 points A and B are in HP. Tell me what will be this particular sentence. Always remember, whenever you do any problem in engineering drawing, you have to read each sentence, then you need to come to the conclusions. You should not read everything in a single gulp and try to find a solution. It is not possible. Always you should attack the problem and you will get the solution by step only. You should not simply come to the conclusion very fast. Okay, now it is given that 2 points A and B are in HP. What will be this particular sentence? Now from this sentence I can say that both A dash and B dash should be on XY line. That means say that the front view of both these points A and B are on XY line. That's what I mean by this particular sentence. Okay, now the point A is 30 mm in front of VP. Okay, so what do you mean this? So again, you have just given the top view of this particular point A. I can just get that. Why? B is behind VP. You have simply given that the point B is behind VP means its top view will be above XY line. You have simply given that. Okay, then the distance between their projectors is 75 mm. So what do we mean this distance between the projectors? Remember, I told you that what is a projector in an orthogonal projection? In the orthogonal projection, projector is nothing but joining the top view and front view of a corresponding point. That is a projector. Now since I have given here 2 points, I am going to give 2 projectors. Now these 2 projectors at what distance? He has given that the distance between their projectors. Always remember, the distance between their projectors has to be measured parallel to XY line, or it is in the XY line direction only, not in the other way. Okay, so it is 75 mm distance between their projectors, and the line joining their top views makes an angle of 40 degrees with XY and find the distance of the point B. Okay, now as you can see this particular problem, the front view position of both the points known to me, that is I can just get A dash and B dash. Then the top view of point A is given, but top B is not given. Instead of giving top view point directly, he has given the line joining their top views makes an angle of 45. So always remember, whenever I want to do any problem, I can give the data so that I can find the remaining one. See, always the data I cannot give directly. Remember, I think you have done a lot of problems now. So whenever you do any problems, the solution you are going to get to be such that I will not do direct substitute. For example, you remember whenever I give an equation, if you give all the variables, you will simply calculate. But it is not direct. Indirectly, you are supposed to calculate the distance of that particular point B with reference to VP. Okay, now let us do this. So as usual, as I said, I will draw the XY line first. Then I know that both front view points of this particular A and B will be on XY line. So A dash will be here, B dash. So A dash, B dash, can I take together here? I cannot. Why I cannot take together? Because it is given that the distance between their projectors is 75 mm. So what I do then is, I will consider this as A dash. Then I will consider the distance between A dash and B dash to be 75. So I will take this as B dash. Then I have given the point A is 30 mm in front of VP. That means say that your A should be below XY, because anyway in front of VP means the top view of that particular point should be below XY line. So I have just taken the distance and that is given as 30 mm. So I will just write this. This is point A and this distance is 30 mm. Now, and B is behind VP. What do you mean B is behind VP? That means say that the top view of that particular point B should be above XY line. That's what I told you though. If I say point is in front of VP means top view will be below XY line. If I say point is behind VP means top view is above XY. So now I know that top view should be above XY line. So I will simply draw a projector like this. But I don't know this distance. But what is that I have given? Instead of giving this distance directly, I have given indirectly another statement. What is that statement I have given? I have given the line joining their top views makes an angle of 45 degrees with XY. So this is XY line. And the line joining them. So let us say if I cannot randomly join. If I randomly join, that angle may be anything. But now I have given that the angle wherein this particular line joining A and B should make an angle of 45 degrees with reference to XY. So what I do is, with this as a point, I will just take this particular line 45. Anyway remember, with the XY line means this is also parallel XY line now. So here it will take 45 degrees. So I will take this 45 degrees. Then I will extend this. And this angle should be equal to how much, as I said? It should be 45 degrees. Wherever it intercepts, that point will be your point of point B, which is behind VP. So I will get this to be point B. Okay. Then we are supposed to determine what is the distance of the point B from VP. That means what I should do then? I need to measure this distance. So measure this distance. That is the distance X. And just put it there. So that's all. So as you can see, I have given one data, but in the previous problems and all, I would have given this distance of the point B. Then I would have also told you to join their top views and find their angles. So that also I can give. Or I can also say that join AB in this case. But anyway, in this particular case, if I join AB, it is an XY line. Why it is an XY line? Because we know that the front view of both the point A and B are on XY or on HP itself. Is it clear?